Hi, my name is Kelvin, and today we are revising this past paper from last year, October-November session. And this is an non-calculator paper. So for those of you who are preparing for your May-June exam this year, I'm wishing you all the best, and I hope this video will be of a lot of benefit to you. So without further ado, let's begin. So we'll start with the first question. We'll just ease in. And I know the paper kind of does that. We start with the easier questions and then they get a little bit more challenging as we move on. But don't worry, I believe you can do it. And the fact that you're here, it shows that you really want to do this. So let's begin. And in this first question, we are looking at, we are told the temperature at 4 a.m. is negative 12 degrees Celsius. And the temperature at 4 p.m. is 21 degrees Celsius. So you basically asked to find the increase in temperature from 4 a.m. to 4 p.m. And in a question like this, it's a question that is basically just want to test your knowledge of directed numbers. And of course, you can ask yourself from negative 2, that is negative 12, from negative 12 to 0, and then from 0 to 21. So basically, just get the difference. And you can see here we have basically an addition of 12. And then from 0 to 21, that's an addition of 21. So you get 12 plus 21, that will be 33 degrees Celsius. So that will be our answer here. Okay, that was easy. Check the second one. Says find all the common factors of 8 and 12. Notice it says all common factors. So the best way to handle this question is to list all the common factors for both of the numbers. So I'm going to list the ones for 8. I'm going to start with 1, and then I think 2 and 4 and 8 itself. So yeah, those are all of them for 8. And then for 12, we can also start with 1, and then also 2 works, also 3 works for this one. 4 also works for this one, 6, and yeah, the last one is 12. So let's find out the common ones. You can see this one, and then this one. So you can say all the common factors are 1, 2, and 4 for both 8 and 12. And that will be your answer. Okay, nice. Now we move on. We're told a cuboid has a length of 4 centimeters. A cuboid looks like that. Has a length of, okay, we can say 6 centimeters, a width of 5 centimeters, and a height of 2.5 centimeters. So it says work out the volume of the cuboid. So to calculate the volume of a cuboid is usually length times width times height. And in this case, we have the length, which is 6, times width, which is 5, times the height, which is 2.5. Okay, so we don't need a calculator, we can do this because this bit is 30. 30 times 2.5. Okay, this 0 can actually remove this decimal point, so you're left with 3 times 25, which is 75. So you can say the answer is 75 centimeters cubic for that question. Okay, nice. So let's move along. So you're told a computer costs $560. So that's like the original price or the price before any reduction. So we are told in a cell, the cost is reduced by 20%. So always remember something, the original price is always 100%. So you can say 560, this is 60, sorry. $560 is represented is equivalent to 100%. And then this is reduced by 20%. So that means the new price is like 80% less, right? So to figure out what that price, you can actually use cross multiplication, because cross multiplication is one of those direct proportion concepts. Okay, yes, just a shortcut for direct proportion. Because with the reduction of one thing, the other one also reduces. So anyway, we'll just use cross multiplication here. We have 80 times 560 over 100. Okay, so 80 times 560 over 100 will get, okay, this is 56. We don't have a calculator, we're not allowed. We can just do these things the old-fashioned way. This is 6 times 8 is 48, carry a 4. And then 8 times 5 is 40, 40 plus 4 is 448. So you can say the new price is $448, which is really nice. It's a great reduction. You kind of save more than $100, which is a very good bargain. I would buy this one. Anyway, let's move on. So you have a question on pi. So touching on the topic of statistics here. So for this question at all, the pie chart shows some information about the way 600 students travel to school. So we're told, okay, this is 90 degrees. So I remember, actually in a pie chart, you should remember a pie chart, a full circle will give us 360 degrees. So we can say 360 degrees represents 600 students. Now we can actually now use that to allocate or to find out the number of each student or the degree based on what the questions asked. So let's see what the question is asking. So the first one is saying, work out the number of students that walk to school. So walk to school, we have, that is 90 degrees. So if 360 degrees represents 600 students, what would be 90 degrees? So you can just do a cross multiplication again here. So this would be 90 times 600 over 360. Okay. Alternatively, for those of you maybe are not very familiar with cross multiplication, you can just take 90 over 360 times 600. Okay, it's basically 90 over 360 of 600, and then you can figure out the number. So you can just cancel the 0 and 0 here. By 6, 10. By 6, this would be 6. And then by 3, 2. By 3, it would be 30. By 2, 1, can just do by 2, 15. So 15 times 5, we can say the students will walk 150 students. Okay, and we can actually do that here, 150 students. So remember to write students, because here this omits the units, but anyway, I think you still get the marks. Okay, yeah, although we should also do the calculation here, but I'm sure most examiners will be able to see you did it here. So just do it here. 20 over 360 times 600. Of course, this one will give us 150, which is what we have there. Okay, so far so good. Now we are told 120 of the students travel to school by car. The remaining students travel by bus. Complete the pie chart. Okay, this is good. So we know 360 degrees represents 600 students. And we want to figure out what degree represents 120 students. Figure that out. So we can basically do a cross multiplication again. 120 over that's 120 times 360 over 600. So this 0 will cancel that. That one will cancel that by 6, 1 by 6. So that will be 2. Yes. So 2 times 36. This will be 72. And this is in degrees. Now, this one is actually not drawn to scale. So for this one, you'll have to use your protractor to measure the 72 degrees. And actually, I will use my protractor here. I know you can't see it, but you use yours. I'll just lay it and align it with a 90-degree line, or the line that is very perpendicular. Okay, and then I'm just going to get to 72. So in my protractor, my 72 is here, somewhere here. So I'm just going to use my ruler and just connect that to that point. Make sure you use a protractor here, and I help you get it accurately. Hey, not so accurate, but I think you get the idea. So we know this is 72 degrees, and we know this is bicorn. Now, if you already know that, we know like a total of this will be 360. So we already have like 72, we have 72 plus 90 plus 60. Okay, I think this gives us, if we do, okay, yeah, this gives us 222. And if we subtract that to 360, we get the remaining degrees, which will be this one here. And I think it will be 360 minus 222. And this one will be, excuse me, 138. Yes, if I'm not wrong. Yes, it's 138. So you know the remaining ones, that is represented by 138 degrees, will be those students who travel by bus. Yes, correct. Okay, nice. So far, so good. In case you still don't get some of these things, please leave your comments below, and I'll try to like help you personally. But anyway, let's move along. And on number 6, excuse me. On number 6, we are told, okay, we have a shape here, not drawn to scale. So we're told ABCD is a quadrilateral. E lies on line CD, and AE is parallel to BC. AE is here, parallel to BC. And then you're told EA is equals ED. So these lines EA and ED are basically the same. And then the question is asking us, find a angle ABC. So let's find out that angle. Always remember, when you're looking for the angle is usually given by where you're going to find that middle letter. In this case, this is the angle we are being asked, where B is. So it's angle ABC. So looking at that angle, we want to figure out how do we get that. And one thing, we have parallel lines. And if you know the idea of parallel lines, I can actually extend this a little bit. Just extend this a little bit. Okay. And then I can also extend this a little bit. I want you to see something. We know this is a parallel line, and usually when we have a parallel line, this line here is the transversal line. We know if a transversal line kind of goes through two parallel lines, we kind of have some properties we definitely have to remember. For example, this angle here, 75, is going to be equals to this angle here. This 75 degrees. Okay. So the reason being, we call that those alternate angles. They're basically equal. And therefore, if that is 75 and this is a straight line, angles on a straight line is 180. If we subtract 180 minus 75, this angle here will be 105. Okay, so that's 105. So angle ABC, we can say is 105 degrees. And then we're told to find out what is angle AED. 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 Again, we have two parallel lines. If I extend this a little bit like that, okay, again we have, okay, now we have what we call like corresponding angle. This angle is usually equals to this one, because remember our transversal line is this one here. Okay, so this angle here is going to also be 80 degrees. Okay. Alternatively, you could add 75 plus 105 plus 80. You'd get this angle here. First angle is in a quadrilateral, 360. You'd have to subtract whatever the sum of these three angles are. And then this angle in a straight line, you'll be able to now get this one. Okay? But I think the idea of like parallel lines and transversal lines it's very useful. You get them a little bit quicker. And if you do that, you already know if this is 80, we can actually get these angles very quickly because these lines are equal. So it means the sum of those two angles are equal. So if we divide those two angles by 2, we're going to get this one is 50 and this one is 50. In case there's any question that asks on those, we can actually already have the value. So let's see. Okay, this one we found out was 80 degrees. The other one was angle DAB. DAB, yes, DAB. So D is here, A is here, and B. Basically, they are telling us to find this angle here. And of course, you can clearly see it's easy because you have 75 and 50. So that will be 125. So that angle will be 125 degrees. Okay, so far so good. I'm sure like you're seeing that the paper was really, really friendly, especially at the start. Then you're told for number 7, represent the inequality -4 is less than x, which is less than or equals to 3. Okay, I like reading from where x is, because x kind of directs me. So I like saying x is greater than -4. So -4 is here. I'm just going to draw a small circle there. I won't shade that. But this tells me anything in this direction is greater than x. But then we also have another condition here whereby we're told now x is less or equals to 3. So where there is 3, I'm just going to stand there. And this time I'm going to shade this circle. Reason being, 3 is inclusive because it says x is less or equal. So usually when it's less or equal, usually the equal one kind of makes you shade. You're supposed to shade that small circle you have there. And then we will draw use a ruler and just draw a straight line. Here, I won't use a ruler. My screen is too smooth for me here. But because you'll be having the physical paper, that is how you represent that inequality. Okay. If you are still struggling with inequalities, you want to make sure you have a good grasp of this. So it's a very, very easy concept. Once you get a hang of it, you're good to go. Okay, great. So that's number 7. Let's move on to number 8. Number 8 says Kemi buys P pens that each cost 40 cents. She pays with $20. Write an expression in terms of P for the change in cents Kemi receives from the $20. Okay, one thing, because this is bold, I'm just going to change the dollars into cents. I'm going to do $20. I remember $1 is equals 100 cents. Multiply by 100. and I get 2,000 cents. So I just wanted to change that so that I get that out of the way. Now let's break down this question. So Kemi buys P pens. That's a number of pens we don't know. Okay, but one pen is 40 cents. So this will mean Kemi buys, if one pen is 40 cents, if we multiply, we'd have the number of pens times the 40, we can get the amount of money that Kemi pays for all the pens, right? Because we are told she bought P pens, which we don't know how many those are. Okay, but one is 40 cents. So if we multiply by 40, multiply by 40, we get the total amount she paid for all the pens. I hope that makes sense, and it's clear enough. This will be 40p. Okay. Now for the expression would be she paid $20, which is equivalent to 2,000 cents. If we subtract this with what she paid in total for the pen, we will get the balance. And this is the expression the question is asking. You're not solving. Remember, an expression, you're not solving. It's different from an equation, okay? An equation you solve. If it's an equation, you would have solved for P. But for an expression, this is how you're going to leave it, okay? Okay, so let's move on to number 9. So for number 9, it says, Rajid has a full bottle of juice. He drinks a third of the full bottle on Monday. He drinks 3/7 of the full bottle on Tuesday. And then you're told to find the fraction of the bottle of juice remaining. Okay, so a question like this, we just break it down. So this is on Monday. We just pick on Monday. This is what he drinks. And then on Tuesday, this is Monday. And then Tuesday, we have 3/7. This is Tuesday. Okay, now we can actually add to get to know how much he drank for the 2 days, right? Because if we add, we will get to know this is this is the fraction or total for both days. So we can just do 1/3 plus 3/7. Okay, this is addition of fractions. You should know this, whereby we can just use the LCM. In this case, it's 21. And then 21 divided by 3, that's 7. 7 times 1. So it will be 7 there. And then 21 divided by 7, which is 3. 3 times 3 will be 9. So we get, now in the 2 days, the fraction will be 16/21. So this will be the total amount he drank for both Monday and Tuesday. Okay. Now, we are being asked to find the fraction of the bottle of juice remaining. Okay, so for both of the days, excuse me, we know the bottle, like if it's a full bottle, we can represent something full with 1, right? Like 1 is usually like total or full, okay? And then we can subtract this with the fraction of what he drank both Monday and Tuesday. And then we can try to figure out, I can just put this like over 1, and then I'll have a LCM of 21. Okay, this will be 21 minus 16. This gives me 5/21. So you can say the amount of milk remaining in the bottle, sorry, it's juice, not milk, sorry. It's 5/21. So that's in terms of a fraction, that's the amount of juice remaining in the bottle. Okay. Okay. I hope so far I'm making a lot of sense. If I'm not, please feel free to let me know. Okay. Yeah, I'm always willing to learn, and I want to help you the best way possible. Okay, let's move on. So for number 10, we have this information whereby we are told B is equals dm plus 2mk. And then we are told D is 3.14, M is 7.92, and K is 10.16. Okay, by rounding each value correct to one significant figure, work out the estimate for B. Okay, usually for estimation, generally we usually round them to one significant figure. Okay, and remember, the place value of a number is what determines the significance. I've seen people confuse this a lot. They think significant figure is the biggest number. That's not the case. Okay, the significant figure is the number that is at a higher place value than the rest. Okay, so for example, in the first one, D, to one significant figure, 3 is the most significant here, followed by 1, and then 4 finally. Why? Because 3 it's in the place value of ones, whereas actually the other ones are in the tenths, like tenths and hundredths. They get smaller. So anyway, we're just going to look at 3, rounding to one significant figure, not decimal. One significant figure. So D would be equals to 3. We have rounded it to one significant figure, so we just ignore the rest. And M, rounded to one significant figure. Again, the most significant figure is this 7. And okay, 9 is above 5, so we can round by 1 up here. So M will be 8, rounded to one significant figure. And finally, K. K, we have 10.16. So rounded to one significant figure is basically going to just write 10. Okay, just going to discard all of this. 1 is there. Generally, we don't count zeros as significant. That doesn't mean zeros are not important. They're actually very important. But when it comes to significance, we usually focus on values. Okay. Yes, so that's how we can say 10. 1 is the significant figure in 10. Okay. So after this, we can just do, we're told find B. So B is going to be equals to, okay, D is 3 times M. M is 8. Basically substitution here now. Plus 2 times M. M we know is 8. And K is 10. K is 10. So this is 24, because 3 times 8 is 24, plus this will be 16. 16 times 10 is 160. This gives us 184. Yes, 184 is our answer. Okay. Yes. So in case you are still struggling with this, it's a simple concept. Remember, significant figures are numbers determined by the place value. The number with the highest place value is usually the most significant. Okay, let's move on. Part B of number 10. It says rearrange the formula to make M the subject. So we have B is equals dm plus 2mk. So in a case like this, you notice M is in 2 places. It has to be in one place. So the best or the easiest way to think about this is to factor out M. So put M outside the brackets. So once you factor out, we remain with D plus 2k. Okay, and then to get M, remember this one you can just do by division of D plus 2k. And just do that on both sides, D plus 2k, both sides. So this will cancel this bracket. Okay, so M is going to be B over D plus 2k. Okay, yeah, so it's easy as that. Just remember, when you're rearranging something to make the subject, you want to be left on that thing you are rearranging on one side, and it's supposed to be alone. Don't want it to have anything else. Okay. Okay, good. Let's move on. So we're going to move on to number 11. So for number 11 is saying, okay, in the diagram, S lies on PQ and T lies on PR. ST is parallel to QR. So, okay, I like parallel lines because I like extending them. You're just going to extend them a little bit before I even look at the question, because I feel like we might need that information. So I'm just going to extend this bit. Yes, transversal lines with parallel lines, really, once you have that information comes a lot. It's very helpful. So it says explain why triangle PQR is mathematically similar. Okay, that word is mathematically similar to triangle PST. And then give a geometrical reason for each statement you make. Okay, this question is rare, whereby you told to give a reason. But surprisingly, they came last year. Yeah, we can just go through this one and find out what are the reasons. So let's try to prove these two triangles are similar. And if you know the topic of similarity and congruence, this topic might actually be a little bit friendly. Sorry, this question might be a little bit friendly. But anyway, let's look at it. We have, we'll just look at some few things. For example, remember I kind of extended the parallel lines, then the transversal line. And because this kind of gives me something interesting, you know, based on parallel lines and transversal line, these are corresponding angles, right? So basically you can say angle P, Q, R is basically equals to angle P, S, T. Why? Remember they say give a geometrical reason. Why? Because they are corresponding angles. Parallel lines, transversal lines give us corresponding angles. So you can basically say they are corresponding. Is corresponding of double R? I don't know. Fine, you'll tell me in the comments below. And based on that, you can actually tell even this one and this one, they're going to be corresponding. So we can just say P, R, Q, and PTS. P, R, Q is equals PTS. So make sure we get that right. Yes. Again, reason, corresponding angles. So these are corresponding. Please confirm if corresponding has double R. I want to mess this up. Okay, but yeah. So, okay, the question is 3 marks. So far, I think we have 2 marks. We can find out. Okay, another thing is that makes them mathematically similar is this angle. Notice like they both share the angle P, this angle there. So you can say like QPR is equals SPT. Okay, let me see again. QPR. We know that's equal, or it's basically they're sharing like that angle, like it's a common angle. So SPT equals SPT. So this is the angle they're sharing. We can say it's a common angle. So they share a common angle. And these are actually the 3 reasons that make this mathematically similar. And remember in mathematics, similar means, it doesn't really mean they're identical. Identical, we usually use the word congruence. Similar basically means they have properties that are kind of the same. Okay, like the angles as we've seen, they're usually like they are the same. Okay, or they are equal to each other. Yeah, especially the corresponding angles. And usually for similarity, we have the idea of factors or scale factors. Okay, so you find that basically the idea is one of the triangle is like an enlargement of the other. Okay, yes, yes, but these are how you give reason to, or this is how you like basically explain why they are similar. Again, I say these questions are not very common, but it's a nice question anyway. Anyway, let's move on to part B. So we're told ST is 3 centimeters. So this one here. This one is 3 centimeters. And QR is 9 centimeters. QR is 9 centimeters. So those are, I can say, like the corresponding lines. And therefore, because of that, they can help us to get what we call a scale factor. A scale factor is basically by what factor you enlarge something. So, and in this case, I can put S on top, which is 3 over T, over QR, sorry, over QR, which is 9. So we can have a scale factor of 1, 3. Okay, it depends on how you want your scale factor to be. Some people will just use 9 over 3, and then they'll have their scale factor as 3 or 3 over 1. Okay, I always like, sometimes I just like to start with a smaller one on top, a larger one at the bottom. Okay, so just simplify it to 3 over 1. And then this scale factor can actually help us find values for any other line. For example, the other line that is similar to PQ is PS. You can see this one. PS is similar to PQ. So we already know PS. We can equate this. We already know PS is 5 centimeters. But PQ, the larger one, PQ, we don't know. But we do know it's part of PS, so it's going to be 5 plus, we still have this distance remaining, SQ. So 5 plus SQ. Now for the whole of it, because remember, PS is just this distance, but we want PQ, which are like the similar sides. Okay. Now to find out what PQ is, we can just use this. I can just like do some cross multiplication here. So I will get 5 plus, I'm going to just write SQ here, is equals, okay, 3 times 5 is 15. Okay, so SQ, I can take this to the other side, or in other words, people say subtract 5 on both sides. So SQ is what? Is, yeah, 10. Remember, this is just SQ. Okay, SQ, let me show you. SQ, this bit is the one that is 10. This other one is 5. The question is asking us to find PQ, the whole of the distance. So of course, you can clearly see this is going to be 15. Okay, that's 15 centimeters. Okay. So just remember similarity, whereby in mathematics, the shape don't have to be identical. They just need to have like corresponding sides which are very like similar. Okay. Yeah, corresponding sides. And most importantly, remember, it's just like an enlargement of the other. Okay. Now, we're told the area of triangle PST is 2k centimeters squared. So that's the smaller triangle, I believe. Yes. Let me just get rid of this. It's making my thing dirty. Okay, yeah, just got rid of that. It's going to keep the basics. Okay, so I'm told triangle PST, the smaller one, is 2k centimeters squared. So you're told find in terms of k the area of quadrilateral QRTS. Okay, before you even look for the area of that quadrilateral, can we use the area of the smaller triangle to find the area of the larger triangle? And the answer is yes. Okay, so when you have area, we're going to use our scale factor. Remember, we had gotten our scale factor earlier, was 1/3. Now, when it comes to area, we're going to adjust the scale factor to have something called area scale factor. So area scale factor. And to get an area scale factor from the linear or the normal scale factor, we just need to square the normal scale factor, the linear scale factor, in other words. So get, this is 1/9, okay, because 1 times 1 is 1, 3 times 3 is 9. So the area scale factor is 1/9. And the reason for this is because we just want to maintain like the proportionality of the concept, because here we are dealing with areas. We're no longer dealing with lines, right? We're dealing with areas. So when you're dealing with areas, we have to adjust to dealing with areas, and that's why we need the area scale factor, so that when we are doing the comparisons, we do them in a way that makes sense. So this is 1/9, and again, 1/9. The top value usually, in this case, will represent the smaller shape. In this case, our smaller shape is PST, which is 2K centimeters squared. And now to get the area of the larger shape, which is triangle PQR, I'm just actually going to write the area of PQR. PQR. Okay, just going to write it like that. Yes. So if I cross multiply, I get area of PQR. PQR is equals 9 times 2K, which gives me 18K centimeters squared. Now that's the area of that triangle PQR. Now remember, the question is asking us to find the area of quadrilateral QRTS. So this one here, this is the shape we are being asked to find the area for. Okay, QRTS. So of course you can see together shape, you just need to subtract the area of the polar shape or the bigger shape minus the area of the smaller shape. We know the area of the smaller shape was 2K centimeters squared, and the area of the larger shape is 18K centimeters squared. So you can just do 18 minus 2, so 18K minus 2, okay? 18K minus 2K, and this gives us 16K. So the area of that shape is 16K. Okay, yes. Okay, very nice, very nice. So I think I'm going to take a break now, and then after the break, I'll just continue from number 12. Okay, see you in a short while.